Welcome to the video on applications of power electronics in power system. In this video, we are going to see one numerical on the series compensation of the transmission line. Here in this problem, what is given? A power system is having the voltage at receiving end and sending end is 1 per unit and angle between them is 30 degree. So we have one power system with us. So let us take power system that is one sending end bus and one receiving end bus. The receiving end voltage is given, if you take a reference, it is 1 at an angle of 0 degree it is given, and sending end voltage is given as 1 at an angle of 30 degree because angle difference between them is 30 degree. The line reactance is given as 0.4 pu. The line reactance is given as J zero point 0.4 per unit. So here we have to a series compensator is add in the transmission line. So in the same transmission line, keeping the sending end and receiving end voltage at the same level, so Vr is equal to 1 per unit and Vs is equal to 1 at an angle of 30 degree. So here we are going to add one compensator in the transmission line. So let me delete this. Here we want to add one compensator in the transmission line such that this voltage introduced here, it is a 0.2 at an angle of 105 degree. Still the line reactance is J zero point 0.4 per unit. This is the X. We have to calculate the current to the transmission line before and after compensation, power transfer, and the impedance introduced by the compensator. So let us calculate the current, the first case. The current without compensation, the I phasor is given by Vs phasor minus Vr phasor upon transmission line reactance. So Vs phasor is 1 at an angle of 30 minus Vr phasor is 1 at an angle of 0 degree upon the line reactance is J zero point 0.4 unit. If we calculate this value, so let me check how much it is coming. It comes to 1.294 at an angle of 15 degree. Okay, so same current we have to determine the after compensation. So after compensation, the current will be Vs phasor plus Vc phasor compensator current, compensator voltage minus Vr phasor upon line reactance Jx. That is 1 at an angle of 30 plus zero point 0.2 at an angle of 105 degree, zero point 0.2 at an angle of 105 degree minus 1 at an angle of 0 upon J zero point 0.4. So let me check how much current it is coming. 1 at an angle of 30 plus zero point 0.2 at an angle of, you can also verify on the calculator, 105 minus 1 upon zero point 0.4 I. Take the answer in polar mode. So it comes to 1.794 at an angle of 15 degree. So you will get this per unit current after compensation. Now, in second case, we have to calculate the power. So power transfer before compensation, you can calculate using the formula real value of Vs phasor into I phasor conjugate. This is one of the formula, or you can use formula mod of Vs into mod of Vr upon mod of x sine delta. So if you use both formulas, you will get the same result. So 1 into 1 upon zero point 0.4 into sine of 30. So this power transfer we will get in this case as 1.25 per unit. So this is the power transfer before compensation. After compensation, the power transfer can be calculated using the first formula. Real value of the multiplication Vs phasor and uh, so Vs phasor multiplied by I phasor conjugate. So if we see here, real value of Vs is 1 at an angle of 30 multiply with 1.25 multiply with 1.794 at an angle of 15. So if we multiply this, we'll get the answer. Take the real value of that answer. Imaginary value will indicate the reactive power. So you have to take the minus 15 over here because we have to take the I conjugate. So I conjugate will give you minus 15. Okay, the power transfer will be 1.732 or 1.733 per unit. So see, before compensation it was 1.25, after compensation it is 1.733. So by adding a series compensation, the power transfer capability, power transfer of the line is increases. Now we have to calculate the impedance introduced um, by the compensation. So we have a compensation voltage and we have the current after the compensation. From this, it is very easy to calculate the uh, impedance offered. So third case, impedance offered. The impedance offered by the compensator is nothing but the voltage injected by the compensator divided by the current. So voltage injected by the compensator is zero point 0.2 at an angle of 115, and the current which was injected, it is 1.794 at an angle of 15. 1.794 at an angle of 15 degree. So how much it is appearing here? So let us check. So zero point 0.2 divided by 1.794. So this will give me 0.1115 at an angle of 90 degree. So what it indicate? It is the J.1115 per unit. Means this is the capacitive reactance which is added in the transmission line. So as the sign is coming as a sign is coming as the plus here. Okay, so the capacitive reactance is added in the transmission line. So we see by I. So 115 divided by 15. So this will give you the 90 degree. So that is plus J 115, that is the capacitive reactance of Xc is added in the transmission line to increase the power transfer capability. Uh, hope uh, hope you have understand this problem. We'll see the next problem. In that we'll see this different values of the it will see the different values of the compensator. Okay, so with this we are at the end of video. If you like the video, subscribe my channel and share with your friends.